Really excited to be here today. Very interesting event, and I was really excited to be asked. So I want to just get started pretty quickly here. A little bit about me. I think the only thing to really take away from this slide that he hadn't already mentioned, and I thought it was a great intro, was that I started off as a developer, and when most security folks start off in the traditional operations roles or they get into it through governance, I started basically building software. So this comes from a perspective of somebody who also has helped to build security as software at my company. I run the red team, which means that I run an offensive security team. We have about 35 people in the role of the red team, and that is pretty large for a red team, which is kind of fun. Also, it means that I herd cats. So, kind of getting into this whole DevSecOps thing, hats off to it. What the heck is happening in this industry? Software is being built, tons of things are happening. All of a sudden we woke up one day and software was eating the world, right? Well, all of a sudden we woke up one day and Agile was eating the world. This was definitely about 18 years ago when they started to build the Agile Manifesto. And for those of you who are security practitioners, it started to change your world because it meant basically the whole world was speeding up. All our checklists were starting to kind of become interesting. Conversations had friction. And this is the 18 years of the 30-year career that I've had that have been really interesting because it's introduced a lot of friction. With that change, really, we got to the point where compute wasn't working. We had to have cloud. We had to have all these different things that were going to help us to evolve. And as you can imagine, cloud actually created a whole bunch of interesting shifts. We started to see DevOps. We were going to merge Dev and Ops together because, oh, by the way, there were easier ways to work on utility computing. It meant that operations folks had to start to code. And so that evolution got started. Now we have multiple evolutions all building onto each other. You're starting to see that basically it means that we're all being asked to change constantly and evolve frequently. Compliance is code. Our compliance folks are governance people. They write lots of documents. They don't write code. How are we going to deal with that change? Eventually, that basically goes from pen testing to red teaming. We see the evolution of red teams that really kind of spawn. And more people basically trying to figure out how to do red team. Even more importantly, traditional security has started to evolve into DevSecOps. And what this map is, so that folks that don't know what it is, it's a Wardley map. It basically is something that we use to kind of figure out what the future holds so that we're always pushing on the most important things at our company. Wardley maps are really interesting. If you haven't seen them before or haven't read anything, Wardley puts out a lot of information. Definitely look them up. So if we know that this is what the heck is happening, how hard could it be to do DevSecOps? And I will tell you that this is a DevOps pipeline. This is basically somebody creating code. They've got really interesting mechanics of building that code and publishing it. And a lot of these things are sorted by a single-use capability. Along the way, what we found out was very quickly that security is very complicated. There's not a lot of single-use, single-purpose tools that actually get built in to support code as it's being developed, which has created a lot of friction in the world for folks that do develop software who are trying to figure out how to make it safer. There are tons of developers out there that are worried every day that the software that they develop is not actually secure enough. So if this is our world, it's really complicated, as you can imagine, as a security professional, where we get so many people dedicated to our function. We're basically usually 1% of whatever the software development team is. So if you have 100 developers, you have 10 operations staff, you have about one person that covers your security realm. And one person to cover all these tools, I can tell you that it's absolutely unachievable. So what are we going to do? So, I obviously got to the point in our journey where there was a lot of head banging. I actually have this sign sitting in my office. It's metal. It hurts a lot. It really helps a lot, too. And I'll tell you, I bang my head even today. And the reason why is because the journey's not written. There's no book to go look at. You can imagine yourselves. You're starting to see these things. If you're not, I'm so sorry, you're going to. Because really, as software eats the world, we're all being asked to basically build software skills. I took on the unimaginable, which was to tell a bunch of security professionals that they were going to have to build code. And to this day, we have about 35 people. They all code. I remember trying to convert a compliance specialist, and he told me that I was insane. I said, you have a year to do it. 9 months later, he came to me and said, were you serious? And I said, yes, you have 3 months left, or you're going to be finding a new job. So to this day, he's also helping to move the DevSecOps movement forward. He is an avid programmer and is working as a lead in security engineering. That's kind of cool. So kind of what's the maturity model? So if you can imagine, like 5.5 years ago, for me, it was waking up one morning and being told, we need you to make this more formulaic so that other people can do it with you. I've been doing this for about 15 years, trying to bang my head against the agile roadmaps, trying to figure out what's going on, how does Scrum work. And I started developing code back when I was really young, and it didn't necessarily transcend into this agile world because I used to follow these things that were really traditional thuds of roadmaps that you basically didn't have to think about because everybody had every requirement ever known to man written down for you. And when you got done with the project, it basically failed. So now this agile word comes into the place. You have this new thing called culture. You've got to figure out people's skill evolution. You have to bring a whole bunch of executives along with you. It's an interesting dynamic. Programs and outcomes. I've gotten into basically figuring out exactly how I'm going to digest an annual roadmap into quarterly outcomes and get a bunch of people who want to be innovative to figure out how they're going to break it down, which means basically my security team does DevOps. They leverage Agile and Scrum. We do a lot of Scrum roadmaps. Sometimes we do fast Scrum, and sometimes we do slow Scrum. And everybody's got a little bit of a different way of doing things. I would say we're not any different. Your security priorities. So I would say that where we are now, my actual goals for the year is get ahead and stay ahead of adversaries. No big thing, right? Everybody can do this. Super easy. Somebody out there has already done it for us. There's already tools, commercial things that you can buy off the shelf. Yeah, sure. So the pixie and fairy dust, get ahead and stay ahead, is a really interesting, big, hairy, audacious goal. And super interesting from the standpoint of changing how you think about what you're going to do. So if you go to the innovation catalyst programs that are out there, which Intuit really subscribes to, you find out that you need to think differently. And thinking differently actually is approaching problems in a different way. So that's how we got to a maturity model. These are some of the behaviors. I would say that the first early behaviors are looking around saying, well, there's no roadmap for this, so therefore it doesn't exist, so I'm not going to do it. And other roadmaps basically tell you that there actually are a lot of people who are subscribing to it, doing this work, and a whole lot of people who have done it who didn't know what it was labeled, so we eventually branded it. So the way to think about this and to put it into perspective is that you have to have a developer brain. And it starts with having a developer brain in a way that maybe all you're doing is automating a very small amount of work. You could be doing something as simple as making your email move every day. I like to say that even scripters are coders these days. With a developer mindset, can you imagine for a moment what they're really interested in? And we kind of created something interesting, which was, and I always am kind of manipulated by the outside world. Nutrition facts labels kind of, started to eat into how we were thinking about things. What if there's only one question you really have to ask to change the perspective of everybody in your organization to get security built into your software? What if that question is, how many adversaries do I have? And I'm not talking about the security team asking that question of themselves. I'm asking that question as a developer. How many adversaries does my software have? How many adversaries does my application have? How many adversaries does my commercial product set have? How many adversaries, right? And if you don't know the answer to that question, it's the beginning of your journey. And my mind-warping way of telling you that you now became a DevSecOps specialist. This question is super powerful. It gets you into things like, well, maybe I'll apply funnel techniques. Developers really think about conversion in an interesting way. They've got a sales mindset. I need to sell my product to customers if I make it truly delightful, and I use things like design for delight. I'm going to actually create conversion. Well, what if we're all going about this adversary thing the wrong way, and what if we're actually going to have to design for a lack of delight? What if we can actually waste the time of adversaries? What if we can find out who they are and get ahead of them? And what if we use the same techniques as our developer brethren? What if we're just cousins? And we just have a different mindset about it. So if you can imagine, you're now just going to change your mindset. You're going to now be chasing adversaries so that you can take that information and provide it back to a developer. Well, that's a little bit more of how it actually operates and in the best way. Imagine for a moment a developer is looking at a library and their question is, well, which one's safer? Which commercial tool out there provides that answer for you easier? They have a library they're going to use. They want to use it early in their pipeline, and there aren't that many products out there. So they want to understand adversaries as a developer. I'm a developer. I want to know who's out there. Where do I go? Do I go start surfing the dark web? How many of you security practitioners would let me loose in the dark web as a developer? Yeah, nobody, right? How many people think that developers don't want to have that information? It's really interesting. What we learned was developers who know more about their adversaries tend to fix things even faster. I used to think that being a 2-day unicorn was impossible. And what I mean by a 2-day unicorn is there were companies out there that were able to get things remediated in 2 days. And we're a 2-day unicorn. We subscribe to our SLAs, we get things done because we actually work on what's important. The things that adversaries are going after, and we triangulate that information a variety of ways. I have petabytes of information that are coming in, and that petabytes of information lead to all sorts of insights. I don't have any problem getting information from developers. Here you go, we want you to take it, go make some sense of it. Developers don't have time to go chase after adversaries and make sense of them. What they have time to do is take your insights and your remediation guidance and do something with it. What we learned was we used to hack, we used to guess what would actually be interesting, and today we don't do it that way. We chase bad guys, figure out what the TTPs are that they're using, we resubscribe to those TTPs, and we use a huge data lake to be able to figure it out. We're leveraging AI and ML. How many of you want to start doing those things? It's incredible work to do. I will tell you that as you think about the new journey you're on as a security professional, you're going to be learning a whole lot more, and it's incredible work. Being able to take apart adversaries, figure out what they're doing, help your company to get ahead. It takes every bit of information you generate, every bit of information that the product generates, every bit of information about the attack surface that you have, and a way of actually putting that into sense for your prioritization. So, if a developer is trying to figure this out, there are basically 3 types of adversaries. A basic, moderate, and advanced type of adversary. About 80% of the adversaries out there from our intel tell us that they're mostly basic attackers. They're trying things. They don't even really try very hard. They're just spraying the internet. And they're getting information back that actually makes it so that they get lucky. If you're dealing with lucky attackers, you can actually get better than they are. So that kind of all boils down into what is kill chain. We've all heard about kill chain in the past with Lockheed. It kind of came up, it was a white paper, and then everybody went, well, how do you do it? And it became complicated, confusing, and some of those things. Now you see MITRE kind of pair in CAPEC, you see MITRE pair in attack frameworks, and what we determined was you can actually use this framework and determine and actually forecast what adversaries are going to do and to what in your environment. 80% of the time. We think that with the advancements of AI and ML, you're going to be able to do that even more frequently. You might even get to the point where you have 100% being able to determine what they're going to go after as it's being published through your development life cycle. So pretty cool stuff. Converting it to human. So I always say that it's really great that we can read that kill chain thing and we know what a C1 is. But imagine for a moment that your CEO speaks kill chain. I have a CEO who speaks kill chain. He understands adversaries. It's pretty darn cool. And the way that that happened was through converting it to human. We have this thing called grades. We basically grade everything. Those B10, C20, that's basically how we go through. And what we give back is we give a remediation guidance that has a grade that as a developer, you don't need to know anything about CVE, CVSS, or any of these methodologies that a security practitioner might use. You just know that that's an F and you need to fix it within 2 days. And so we super simplify it for our developer folks, and it makes it a lot easier. And by the way, we're developer folks too, so we kind of like it because we don't have to think about it. Follow the guidance, get it done, and by the way, it goes away. So the other thing that we learned was we need to be continuously security testing. This doesn't just mean spraying and praying and basically using any scanner out there to be able to find what you think an attacker is going to be doing. It actually means going after and using the science of what an attacker is doing to you, what they will do to you, and leveraging everything out there that you can get your hands on. We do leverage every scanner that we can get that's commercially available. We also leverage things like Metasploit. We've made modules that we've committed. We're constantly building scripts to break into stuff. We take POCs in and make them better. And if you can imagine, it became a huge arsenal and attack framework. I think the thing that is really interesting is that what we started to see in our data was that we could get ahead, that as we posted stuff, it wasn't necessarily interesting to an attacker right off. That even lucky attacks weren't actually finding things very fast. And that if you can actually figure out when something's coming down the pipeline, you can usually forecast before it becomes an F. There's something that's basically become really interesting to us is that everything degrades. Security is just a degradation problem. You put something out, somebody gets interested in it, it degrades the security of the software, and then all of a sudden you have to do something about it. Basically, the notices that we're getting, Meltdown and Spectre and Heartbleed and all these things that come up, they're just security recalls. It didn't get done the right way the first time. You might not have the notion of fewer, better suppliers, but ultimately at the end, it's just a degradation notice. You're simply fixing something that didn't get fixed in the first place. And it didn't get fixed in the first place because somebody was unaware, didn't know how to do something, didn't get feedback fast enough. And what we say in DevSecOps is that feedback is a gift. Feedback has to be faster, it has to be more reliable, and it is our job as security practitioners to make it so that the folks that also participate in security, which is your development crowd, they're actually also getting the things that they need. And so we are basically a service provider, and on my team, to the rest of our organization so that we can supply adversary knowledge and information about what's happening to applications. Can you imagine putting out a security service and having it adopted without too much friction in your company? I can, and the reason I can is because I know how many attackers are hitting the applications, and we're able to convince very simply through saying, here's what's happening to your application. By the way, adversaries out there have recently done some interesting things, like they've changed their tactics with SQL injection. They've gone from simple SQL injections of 1 = 1 to mathematical proofs on a session-by-session basis. That's pretty cool. And how do I know that? Well, the way that I know that is that it comes in through our information feeds, and now I'm able to talk about it with developers who are going to have to fix it. And they're going to have to fix it, and they don't necessarily know how. So unifying security with DevOps, all these tools that have to come back together, they're actually really interesting. What we push on with our commercial vendors is that we want them to make them API available. We want to be able to receive feeds through things like S3 so we can take advantage of data lakes and data capabilities that are out there. We want to be able to mesh data together, and we want to be able to leverage that so that we can turn it into pearls of wisdom and insights for developers as fast as possible. Latency in that conversion process is not good. Just simply integrating these tools into your pipeline is okay, but it's not the ultimate goal. And I think that the thing that I'll also leave you with is a few places to start looking for information. So one of them was our CISO did a talk at RSA last year and did the security hierarchy of needs. Pretty cool stuff. It kind of gets you started with how a developer can start to hone security skills because, by the way, DevSecOps is a scale problem. Everyone in your company makes security decisions every day, and you need a method and a model, not necessarily a checklist, to make them good at making good security decisions. So we leverage the hierarchy of needs to be able to do that. We basically say if you hit these 5 things, then your application is going to be protected against 80%, those lucky guys. And it's going to make it so that you don't have to think about remediation guidance because you're not going to get any problems that come in. The other thing that was really interesting was several years ago, Veracode actually did a full stack attack talk at RSA. And this was also incredible. They talked about the cloud and some of the issues with it. It's old information, but it's really interesting from the standpoint of how you build attack maps and actually how you start to incorporate that into the development process. We leverage threat maps or threat models at Intuit. We also use things called attack maps, so our red team builds attack maps constantly. And then finally, DevSecOps lessons at OWASP. If you haven't seen this, it's got a lot of detail and statistics in it. Fabulous, and was done by Sonatype. They give you a lot of survey details. Hugely helpful in setting up an SDLC that leverages DevSecOps. So I will leave you with the last thing, which is basically, you're going to want to get involved in a community, start to hone your understanding, give back. One of the things that we're constantly thinking about is how do we give back? We're in the middle of revising our DevSecOps program across several companies and participating in pushing more of this information and content out so that more people can leverage it.